Welcome back to section 4 of chapter 2. This is the last section of this chapter. It's a really short chapter, and it's been all about graphing lines using different methods. We started out with the slope-intercept form of the line, and then we moved on to the point-slope form of the line, which is great to get it into that slope-intercept form. And then we just looked at the standard form of the line in the last lesson. Today, we're going to be looking at parallel and perpendicular lines. This will use a lot of the skills that we learned in those first two sections about slope-intercept and point-slope form. In fact, it's basically the same thing. We'll use a little bit of standard form, but that's just to put it into slope-intercept form, generally speaking. So let's see what we have here for a learning target. A learning target, I can write equations of parallel lines and perpendicular lines. So today we're just writing equations. We're not actually graphing anything today. You could graph them if you want to, but the graphing, like once we have an equation, the equation's going to be the same thing we've been working on all chapter. So graphing them is going to be the exact same thing that we've been doing all chapter. So parallel lines. Parallel lines have the same slope. That's what makes them parallel. They go in the same direction. The y-intercept will be different because if they have the same slope and the same y-intercept, it's the same line. But parallel lines have the same slope because they're the same direction. In order to have a line, we need a direction, which is a slope, and we need a starting point. So if we were to write an equation for a parallel line, so we want a line parallel to y equals 2/3 x minus 1 that goes to the point 2, 5. We're going to take the slope from this line and we're going to use the point here that it gives us. And so when I do this, I always start in point slope form because I have a slope and I have a point. And then I take it into slope intercept form. If you want, you can start with the slope-intercept form, y equals m, which is 2/3 x plus b. Plug in your point to solve for b. You can do that if you choose. I am going to say we have y minus the y part of our point, which is 5, equals the slope, 2/3, times x minus the x part of our point, which is 2. So we have a slope and a point. It's in point-slope form. This is the exact same thing we were doing in section 1 and section 2. The only difference here is that we had to know that this is the slope that we were looking for. That's the only difference. Everything else is just practice doing what we've already done. So when we do this, we're going to distribute the slope. So we'll have y minus 5 equals 2/3 x minus 2/3 times 2. Multiply the top, we get 4/3. Right, because this is 2 over 1, so when we multiply the top and the bottoms. And then we can add 5, so y equals 2/3 x. Then negative 4/3 plus 5, we could write 5 as 15/3. Negative 4/3 plus 15/3 is 11/3, which you could also, so it's that, or y equals 2/3 x plus, what is 11/3? Well, 9 would be 3, so that'll give us 3 and 2/3. So you can always make it a mixed number if you choose. Either of these two are perfectly fine for your answers. And so that's how we write an equation of a parallel line. We just get the slope that it already gives us, and we use the point, and then we do what we've already done. So why don't you guys try one? We want a line parallel to 3/2 x plus 2 that goes to the point 4, negative 1. All right, so think about what the slope is. Think about what your point is. Notice that we did not use this at all. That has no meaning in the parallel line. So think about your slope, think about your point. All right, are you ready? All right, go ahead and pause this, then come back when you have it in slope-intercept form, and we'll do it together and see how you did. Did you get it? Do you think you have it? All right, well, let's check. Our slope is 3/2. So we'll have y minus the y part of the point, which is -1, so that makes that y plus 1. Did you do +1 or did you do -1? If you did -1, maybe pause it and see if you can make your corrections really quick. All right, equals our slope, 3/2 times x minus 4. We're going to distribute the 3/2 to get 3/2 x minus 3 times 4 is 12. So we have 12/2, which also goes by the name 6. Subtract 1 from both sides. So y equals 3/2 x. -6 minus 1 is -7, right? It's not 5 or -5. -6 minus 1 gives us -7. That would be a pretty common mistake when you have two negatives there. All right, so that's the parallel line that we're looking for. How'd you do on that one? Did you do okay? If you made a mistake, did you see where you made your mistake? All right, so that's parallel lines. Again, it's the same thing we've been doing. It doesn't give us a slope by saying the slope is this. It gives us a slope in an equation. Perpendicular lines, same basic idea. We need a slope and a point. So we just need to figure out how do we get the slope. Perpendicular lines have slopes that are opposite reciprocals. Now that's not quite the same as the same slope. There's a lot more going on here. So if we have a slope like say 2/3, the perpendicular slope, so opposite means we have to switch the sign, so it'll be negative, and then reciprocal means we have to flip the fraction. So 3/2. So 2/3 would become -3/2 for that perpendicular slope. What if we had the slope of -7/15? The perpendicular slope, we change the sign to make it positive, and then we flip the fraction to be 15/7. All right. How about we have a slope of 2? What's going to be the perpendicular slope to a slope of 2? Well, it's going to have to be negative because one has to be positive, the other has to be negative. But then we have to flip it. Well, 2 isn't a fraction. Oh, but 2 is a fraction. 2 is 2/1. So when we flip it, we get -1/2. So that's how we find the slopes of our perpendicular lines. It's going to be opposite and reciprocals. We have to flip the fraction and then change the sign. And then we have a slope, we'll have a point. So let's see one in action. Let's go a line perpendicular to 2/3 x minus 1 that goes to the point 2,5. This might look like the one we use for parallel. It is the one we use for parallel. But now we're going to take this 2/3. What would the perpendicular slope to that be? Our new slope will be -3/2. Then we just put it into our point slope form. Y minus the y part of the point, which is 5, equals our slope, -3/2, times x minus the x part of the point, which is 2. We're going to distribute the 3/2. So we'll have y minus 5 equals -3/2 x. The -3/2 times -2, we have a negative times a negative, so that's a positive. 3 times 2 is 6, divided by 2 is 3. Then we can add 5. So y equals negative 3 halves x plus 8 is going to be the line perpendicular to that original line that goes to the point 2 comma 5. Notice once again, just like with parallel, the y-intercept has no meaning to what we're doing. All we're getting from that original line is the slope. So try one for yourself. We have y equals 2/3 x plus 2. No, 3 halves x plus 2. And it goes to the point 4 comma negative 1. All right, so think about what the slope is on this line. What do you have to do to get the slope of the perpendicular line? And then put it into an equation and then get that into slope-intercept form. All right, go ahead, pause me, and then come back when you're ready. Do you think you got it? All right, well, let's take a look. So the first thing is we have the slope is 3 over 2, which means the slope of our perpendicular line, it needs to be negative. It'll be 2 over 3 because we have to flip it. And we have our point is 4, negative 1. So we're going to go y minus that negative 1 is going to be plus 1 equals the slope, negative 2/3, times x minus 4. Distribute that negative 2/3. So we have y plus 1 equals negative 2/3 x. Negative times negative is plus. 2 times 4 is 8/3. Then subtract 1. So y equals negative 2/3 x. 1 is 3/3. So 8/3 minus 3/3 is plus 5/3, which we could also write, if you like mixed numbers, negative 2/3 x plus 1 and 2/3. Either of those two ways works. So how did you do on that one? If you did well, awesome. If you made a mistake, do you see what happened? Do you see where you made that mistake? Did you forget a negative? Did you add wrong? Did you forget to flip the slope? Right? So that assessing, seeing like, all right, I made the mistake here. All right, I'm gonna not make that mistake again, is a huge part of the learning process. All right, so then the last thing we have is classifying lines. Classifying lines, there's no extra skill here. Like, we've done what we need to do. This is just asking, are the lines parallel, perpendicular, or neither? If they're parallel, they'll have the same slope. If they're perpendicular, the slopes will be opposite reciprocals. And if neither of those two things happen, then they're neither parallel or perpendicular. And most lines are going to be neither. Not the ones that it's going to have you look at, but just most lines in general aren't parallel and they're not perpendicular. So let's see how we would do this. Are the graphs of the equations 3y equals negative 4x plus 6 and y equals negative 3/4 x minus 5 parallel, perpendicular, or neither? So notice that they're not both in slope-intercept form. That would make it super easy. The very first step, put them in slope-intercept form. The second one here is already in slope-intercept form. We have the slope as negative 3/4. All right, so now let's put the other one in slope-intercept form. We have 3y equals negative 4x plus 6. We're going to divide everything by 3 because we need it to be y equals. So y equals, we have negative 4/3 x plus 6 divided by 3 is 2. If this doesn't come out nice, who cares? You don't care about that number anyway. The only thing we need from this is that negative 4/3. So we have negative 4/3 from this one, and we have negative 3/4 from the first one. So the first question is, are they parallel? Which would mean that they're the same. No, they're not the same thing. Negative 4/3 and negative 3/4 are not the same. Second question, Are they perpendicular? Which means are they opposite reciprocals? Well, they are reciprocals. We have 4/3 and we have 3/4, but they're both negative. So that would again, so it's no to being parallel, no to being perpendicular, which means that these two are neither. So that's all we have to do to classify them. We find the two slopes. Are they the same? If yes, they're parallel. Are they opposite reciprocals? If yes, they're perpendicular. If no to both of those, then they're neither. And that's it. So notice this was a lot of just using those same skills that we have already used in the first few sections of the chapter. The only thing we're doing is we're getting our slope from another equation instead of just being given the slope or having to find a slope from points. Um, so I think that's probably a pretty decent way to finish off a chapter because it gives you the practice doing all the stuff that we were doing earlier in the chapter. Um, but it does take practice. So I will see you in class though, but until then, keep working problems, keep asking questions, and as always, happy mathing.